Micron and SK Hynix joined the $1 trillion club amid AI memory chip frenzy. ByteDance projects a gargantuan $70 billion AI capital expenditure for 2026. Google CEO Sundar Pichai says AI is reshaping the entire web. Welcome to Nuku.com, your daily dose of AI know-how. The single biggest threat to the global economy isn't a market crash or inflation, but a memory chip shortage, while simultaneously, the world's most powerful religious leader is calling for the complete disarmament of the very code running those chips. The whiplash is just incredible. We are now in a war of pure brute force physics. The biggest bottleneck on Earth right now isn't mathematical brilliance. It's hardware attrition. It is a complete structural rewiring of how capital flows into technology. If you are trying to figure out where the tech sector is heading over the next 5 years, you have to stop looking at the software layer. That is hard because the software is the flashy part. But the software is just the weather. The hardware is the tectonic plates, and those plates are shifting at a violent velocity right now. Just look at the market milestones we crossed this week. Micron and SK Hynix just vaulted into the $1 trillion market cap club. We really need to understand the absurdity of that number. $1 trillion for companies that effectively just manufacture memory. Not the sexy foundational models, not the consumer-facing chatbots, just the raw, unglamorous storage. So how does a memory chip manufacturer become as valuable as the GDP of a mid-sized nation overnight? Because memory is no longer just storage. It is the fundamental speed limit of artificial intelligence. Everyone naturally fixates on the GPUs, the graphics processing units from companies like NVIDIA. The GPU is the brain doing the actual mathematical heavy lifting. But a GPU is a starving beast. It needs to be constantly fed data. If you cannot push data into that processor fast enough, the GPU just sits there idling. It's wasting time, and more importantly, it's wasting power. It's basically an input-output problem. You can have the most powerful bullet train network on the planet, but if only one tiny factory makes the wheels, the whole network stalls out. That is exactly the physical problem the industry hit, and the solution they engineered is HBM, or high bandwidth memory. This isn't your standard DDR RAM that you slot into a consumer laptop. HBM literally stacks memory chips vertically, microscopic layer upon microscopic layer, and places them physically adjacent to the processing core on the exact same silicon package. By doing that, they create this massive, multi-lane, ultra-fast data highway. Instead of a chef having to walk across a massive warehouse to get to a single pantry door, you've essentially built a personalized pneumatic tube system that shoots ingredients directly onto their cutting board. It minimizes the physical distance the electrons have to travel, which maximizes throughput and minimizes latency. But here is the terrifying reality driving those trillion-dollar valuations. Manufacturing HBM is incredibly difficult. The failure rates on the manufacturing lines are super high, and the packaging technology is heavily proprietary. And as of this morning, the entire global supply of HBM for 2026 is already completely sold out. Every single high-bandwidth memory chip that will be fabricated on planet Earth this entire year is already spoken for. If you are a mid-tier tech company trying to build an in-house AI cluster today and you decide you need HBM to remain competitive, you cannot buy it. You are locked out until 2027 at the earliest because the hyperscalers ate it all. The Googles, the Metas, the Microsofts, they bought the entire global supply before it even rolled off the lithography machines. That completely explains the absolute frenzy we are seeing in the broader markets right now. When you have that kind of guaranteed locked-in supply chain reality, the macroeconomic fears just evaporate. We have inflation concerns, we have interest rate debates, and yet the S&P 500 and the NASDAQ are repeatedly shattering record-closing highs. The market is just looking past every traditional economic indicator because the sheer gravitational pull of this AI infrastructure build-out is so massive. It creates its own gravity. You can feel the intense anticipation building around potential IPOs for OpenAI and SpaceX. The entire street is basically holding its breath for upcoming Salesforce and Snowflake earnings, purely to gauge how much of this infrastructure spend is actually translating into broader technology sector health. But the scale of the spending is where human intuition just starts to fail. The numbers are getting so large, they detach from reality. Look at the internal projections for ByteDance that are circulating right now. They are actively preparing for a capital expenditure of $70 billion in 2026 alone. That isn't R&D. That is physical concrete, steel, silicon, and copper. And they are funding it directly from a massive $50 billion profit pool they generated last year. They're taking every cent of profit from TikTok and their domestic apps, and they are converting it into pure compute power, plowing it right back into the ground. They are building massive global data centers and aggressively trying to secure sovereign AI chips to run localized foundation models across all their consumer endpoints. It feels like an arms race where the cost of a single bullet is $1 billion. Anthropic just committed a staggering $200 billion over the next 5 years to Google Cloud infrastructure and AI chips. $200 billion. Is this even sustainable? It is a war of pure financial attrition. The strategy is clear. Spend so much money on infrastructure that you bankrupt your competitors before the software even launches. And that brings us to the hardware supremacy battle happening at the very top of the food chain. We just saw the benchmark leaks for NVIDIA's new Vera Rubin CPU, and those numbers are a monumental structural shift in data center architecture. The Vera Rubin CPU features 88 proprietary Olympus cores. When you run it against the traditional x86 architecture benchmarks from Intel and AMD, it doesn't just beat them. It basically renders them obsolete for AI workloads. To unpack why x86 architecture is a bottleneck, you have to realize that for decades, x86 has been the undisputed universal language of the enterprise data center. It's an instruction set architecture, essentially the foundational vocabulary that software uses to talk to the physical hardware. Intel and AMD have held a duopoly on that vocabulary forever. It is incredibly versatile, which is why it runs everything from your banking servers to your personal laptop. But versatility comes at the cost of hyper-specialization. It's like using a universal translator app. It's great if you need to talk to anyone in the world, but if you need 2 surgeons to communicate instantly during an operation, that translation layer slows everything down to a crawl. When you have a cluster of 10,000 NVIDIA GPUs trying to train a massive neural network, they need to pass petabytes of data back and forth instantaneously. If they have to route that data through a third-party Intel or AMD x86 CPU to coordinate the traffic, it creates a massive latency spike. So NVIDIA just cut them out. They designed the Olympus core specifically to speak their own proprietary, ultra-low latency language, entirely bypassing the x86 monopoly. From the silicon to the networking cables to the software stack, NVIDIA owns the entire vertical. And while the hardware layer is violently consolidating into monopolies, the software economics are exploding in a very unexpected direction. If you want to know where the smart money is moving right now, you have to look at Cognition AI. They just hit a $26 billion valuation after raising $1 billion. The valuation is eye-watering, but the underlying revenue velocity is what actually matters here. Their annualized run rate went from $37 million to $492 million in exactly 12 months. That is a vertical launch trajectory. Going from under 40 million to nearly $500 million in recurring revenue in 1 year tells you everything you need to know about the current state of enterprise AI. The venture capital isn't flowing to companies trying to build base foundation models anymore. We are past the era of funding the next ChatGPT. Capital is consolidating intensely around enterprise agent workflows. The distinction between a chatbot and an agent is so critical here. A chatbot waits for you to ask it a question, and it generates text. An agent acts autonomously. You give it a high-level goal, like auditing thousands of lines of code, finding security vulnerabilities, writing the patches, and deploying them to the testing server. And the agent executes that multi-step workflow while you go to sleep. Cognition AI is building systems that autonomously design, debug, and ship code. And enterprises are willing to pay astronomical subscription fees for that because it directly replaces operational headcount. The wealth being generated at the top of this funnel is aggressively trickling down to the human talent actually building the physical foundation. Samsung's memory chip employees just successfully negotiated individual bonuses of $340,000, just massive payouts, purely because they hold the keys to the physical manufacturing of these memory chips. But here is the massive blind spot in all of this. You can have a $26 billion agentic software company, and you can commit $70 billion to building massive data centers, but you cannot materialize that compute out of thin air. You cannot defy the laws of thermodynamics. When you plug 100,000 GPUs into a server rack, they get incredibly hot, and they require a staggering amount of electricity. We are slamming headfirst into real-world physical friction. The digital realm is finally hitting hard physical limits. A single generative AI query can require 10 times the electricity of a standard Google search. Multiply that by billions of daily users, and the power requirements are catastrophic. We are seeing severe organized community backlash against these new data center buildouts across the entire country. Coordinated protests from local business owners, farmers, and residential communities are erupting because they are terrified about grid reliability and, crucially, water. When a hyperscale data center moves into a rural county, the baseline electricity demand skyrockets, forcing local utilities to hike rates for everyday consumers. Plus, these facilities use millions of gallons of potable water every single day just for the evaporative cooling systems to keep the servers from melting. In places like California, lawmakers are finally taking a strict, study-first approach to figure out the grid impacts before approving these builds. The corporate response to all this friction has been very revealing. The CEO of GE Vernova publicly acknowledged the severe community pushback recently, but entirely dismissed it as a systemic risk to their growth trajectory. The industry consensus basically seems to be that the infrastructure must be built regardless of local friction. They hear your concerns about your well water, but they have an AGI to train. But the federal government is taking the friction incredibly seriously. The Department of Homeland Security and the FBI are actively tracking what they officially designate as anti-technology extremists. This is a direct response to the escalating data center protests and the rising hostility directed toward tech executives. It perfectly illustrates the core transition of this era. Artificial intelligence is no longer just a consumer technology or an enterprise software suite. It is a sovereign asset. It is the core pillar of national security. The geopolitical arms race between the US and China has basically consumed the entire conversation around AI regulation. Just look at the strategic pivot from the current administration. The Trump White House recently abandoned all prior plans for strict federal oversight of frontier AI models. They aggressively expanded the White House AI Advisory Panel, bringing in figures like Pam Bondi with an explicit singular mandate, prioritized deregulation, and rapid deployment. It is a pure accelerationist approach driven entirely by national security fears. The underlying doctrine is that safety protocols, algorithmic bias testing, and environmental reviews are luxuries the United States cannot afford if they slow down the pace of development. The overriding strategic imperative is to maintain compute superiority over China at all costs. But if the United States is sprinting ahead without guardrails just to win a geopolitical foot race, other nations are taking drastically different approaches. Look at Canada. Prime Minister Mark Carney and AI Minister Evan Solomon are launching a highly comprehensive national AI strategy right now. Their framework is the exact antithesis of the American accelerationist model. They are focusing heavily on labor protection, rigorous safety guardrails, and building localized sovereign compute infrastructure, actively aligning their regulatory standards with European middle powers. They basically want to create a distinct worker-centric framework that proves you don't have to sacrifice your society to the algorithmic engine just to stay relevant. Europe, however, is in a massive bind of its own making. The EU has historically led the world in aggressive tech regulation with frameworks like the GDPR, but now they're terrified of being entirely left behind. They're playing a very delicate balancing act with their new digital omnibus proposal. An omnibus proposal is essentially a massive legislative package that bundles several different regulatory shifts into one giant vote. What the EU is trying to do here is quietly walk back some of their own strict rules. They are looking to loosen specific constraints under the GDPR and the AI Act, and they are desperately trying to extend the August 2026 compliance deadline for high-risk AI systems. They want the optics of safety, but the reality is they know they are hemorrhaging competitive edge to the US and China. It is a profound realization that strict regulation might just be a recipe for technological irrelevance. We are even seeing foundational legal systems morphing to accommodate the speed of the technology. The UK Supreme Court just completely reset their entire framework for patentability when it comes to computer-implemented inventions. Historically, the UK used this rigid four-step framework known as the Aerotel test to determine if software could be patented. Essentially, the software had to produce a concrete technical effect in the real world. That makes sense for old software, but AI models blur that line. Is a neural network weights matrix a technical effect or just abstract mathematics? The Supreme Court realized the old test was stifling innovation, so they abandoned it, aligning their standards much more closely with the broader European Patent Office. It is a massive blinking green light to startups, saying, bring your AI intellectual property to the UK, and we will protect it. So basically, everyone is aggressively hoarding their intellectual property, their compute, and their data. This concept of sovereign AI is becoming the defining trend of the decade. We aren't just building global tech platforms anymore. We are building walled, nationalistic data gardens. BNP Paribas, the massive European bank, just dramatically stepped up their strategic partnership with Mistral AI, specifically for cybersecurity and internal deployment. They are deliberately choosing to build their infrastructure on a European regional vendor rather than relying entirely on American tech giants. It's pure digital protectionism. And in the Middle East, the UAE and Saudi Arabia are using their massive sovereign wealth funds to finance hyperscale expansion, but with incredibly strict data localization policies. They are telling the tech giants they will buy their chips and fund their models, but the data generated by their citizens and enterprises can never physically leave a server located within their borders. And it isn't just hardware and data. The most valuable commodity in this entire war is human intelligence. The geopolitical borders are slamming shut on the talent pool. China is actively restricting overseas travel for their elite AI researchers. If you are a top-tier engineer at Alibaba or DeepSeek, the state does not want you attending conferences in Silicon Valley out of fear of defection or corporate espionage. Meanwhile, the U.S. intelligence apparatus is frantically trying to upgrade its capabilities. The White House is currently petitioning Congress for an emergency $9 billion appropriation purely to buy cutting-edge spy chips. They specifically want NVIDIA's Grace Blackwell superchips for the CIA and the NSA because legacy intelligence infrastructure simply cannot process the massive surveillance datasets generated by modern foundation models. Think about the irony here. We spent 30 years building an open internet explicitly designed to erase borders, and now governments are hoarding algorithms, compute clusters, and human researchers like they are stockpiling enriched uranium. While governments fight over macro-level control, the micro-level impact on the individual human worker is deeply paradoxical. We are watching two completely conflicting narratives being pitched from the top of the industry. On one hand, OpenAI's Sam Altman is pushing back incredibly hard against the jobs apocalypse narrative, arguing that AI will drive a massive positive job transformation by elevating humans to higher-level creative roles. But on the exact same day, you can read the internal warnings from executives over at Anthropic who are looking at the exact same capability curves and warning that we are facing rapid, large-scale white-collar displacement that will hit the middle class much faster than any government retraining program can adapt to. We know which narrative the smart money actually believes because OpenAI recently established a highly publicized $250 million worker fund designed to provide microgrants and systemic retraining resources for economies facing severe disruption. When the company building the automation tool creates a $250 million charity fund for the people the tool is going to replace, That is a massive, unspoken acknowledgement of institutional guilt. But the fallout isn't strictly financial. When you look at the massive global enterprise data from Workday tracking employee sentiment, the numbers reveal a devastating paradox. AI is drastically easing raw burnout, with 62% of enterprise workers reporting significantly reduced stress because the algorithmic agents are automating the spreadsheet formatting and the scheduling. The drudgery is gone, but it has been replaced by a profound connection deficit. 33% of all professional interactions in the modern enterprise are now entirely transactional and non-human. You are passing tasks to an agent, reviewing an agent's output, or being assigned work by an algorithmic project manager. Gen Z workers are entering the workforce and finding an incredibly isolated environment. It's like being the only human crew member on a massive, fully automated cargo ship. The ship sails perfectly, but you're just wandering empty hallways as a meat node in a digital network. This isolation has become such a systemic risk to corporate retention that Workday is actually distributing $500,000 in microgrants to nonprofits, specifically to develop pro-social technology. We are literally building algorithms to remind us to talk to each other. The isolation is compounded by the structural mathematical biases being deeply hard-coded into the systems managing them. A massive Stanford study, analyzing over 4 million job applications processed by AI screening tools like Pymetrics, revealed undeniable systemic racial bias. Black applicants face a 10.62% adverse impact rate, and Asian applicants face a 5.32% adverse impact rate, being disproportionately screened out before a human recruiter ever sees their resume. This happens because algorithms simply optimize for the historical human bias found in the training data. This is why states like New Jersey have aggressively codified disparate impact rules explicitly designed to crack down on algorithmic discrimination. Yet the ethical friction isn't slowing down enterprise integration. The mandate from the boardrooms is deploy or die. Jamie Dimon recently revealed JP Morgan Chase has over 1,000 specific AI use cases actively in motion. And he publicly stated he has a $10 to $20 billion war chest prepped exclusively for mergers and acquisitions. If you can't build the algorithm faster than the startup, you just buy the startup. We are rapidly transitioning from an era of AI providing conversational advice to an era of AI executing hyper-financialized actions. Robinhood is rolling out features that allow users to deploy AI agents to trade stocks autonomously. The Liquid Co-Invest app allows retail users to execute complex financial trades directly inside a conversational chat window with models like ChatGPT or Claude. You aren't logging into a dashboard. You are just typing a prompt to hedge your portfolio, and the model executes the transaction via API. Deploying these agents across a massive global enterprise requires intense, hands-on engineering, which is why Fujitsu partnered with Anthropic to roll out the Claude model to 100,000 employees globally using a forward-deployed engineer model. Anthropic is physically placing specialized engineers directly alongside Fujitsu's business units to custom-build AI workflows. This massive systemic shift from humans searching for information to algorithmic agents actively doing the work is fundamentally collapsing the traditional structures of the open web. For 30 years, we searched, clicked links, and consumed content. Now, we are shifting to a model where humans no longer browse the web. We let agents live on the web for us. Google CEO Sundar Pichai is overseeing the most aggressive integration in the company's history, baking the Gemini 3.5 model across the entire Google ecosystem, creating a reality insiders call Google Zero, the absolute death of the outbound hyperlink. With AI overviews, the Gemini model reads a publisher's article, synthesizes the answer, and displays it directly. The user never clicks the link, the traffic vanishes, and the publisher gets zero ad revenue. It is an extinction-level event for digital media. To protect its own revenue, Google is integrating monetization directly into the conversational output, pushing the Universal Commerce Protocol, or UCP. Think of UCP as the new barcode system for the AI age, standardizing how an autonomous AI agent reads a retailer's live inventory and pricing data. Google is trying to monetize the fundamental recommendation and execution layer of the internet. This shift has sparked an absolute gold rush for the underlying infrastructure of the agentic web. Startups like Exa Labs just closed a massive $250 million funding round, while companies like Parallel Web Systems, Tavily, and Tinyfish are raising tens of millions to build headless browsing infrastructure. They are building APIs optimized specifically for AI agents to browse the web, scrape unstructured data, and bypass CAPTCHAs without a human ever looking at a screen. But the reality of these models in production is that they are still fundamentally flawed. Google's multi-billion-dollar AI was recently caught confidently telling users that the year 2027 was 2 years away from 2026. Then there was the disregard crash, where typing the word disregard into a specific search prompt sent the AI overview engine into a catastrophic loop. These models are massive statistical prediction engines. They do not have a true grounded understanding of reality, and the invisible flaws are infinitely more dangerous. Researchers have identified severe vulnerabilities regarding inferential privacy leakage in conversational AI logs. Companies believe that if they strip names and emails from chat logs, they are safe. But inferential leakage proves anonymization is a myth. The models are so advanced at pattern recognition that they can analyze your syntax, vocabulary choices, and contextual references to deduce your age, gender, and country. The privacy leaks from the language itself. This is driving a massive consumer backlash, with DuckDuckGo seeing a sustained spike in user installations as people actively seek out non-traditional link-based search experiences. Before we get into the final takeaways, just a reminder that you can find more insights like this at inuku.com. When you step back and look at the sheer scale of everything we've covered, the narrative of the future is fracturing. We are seeing a profound shift from a software-centric world to a hardware-constrained reality, where high-bandwidth memory dictates the survival of trillion-dollar companies. We are witnessing the death of the traditional internet as autonomous agents replace human browsing, forcing a total reorganization of digital commerce. We are watching sovereign nations wall off their data and their talent, retreating into digital protectionism while the military and the Vatican clash over the morality of automated warfare. The single most important takeaway here is the realization that AI is no longer a tool you hold. It is the environment you operate within. If the fear of recursive AI is valid, and the machine is on the verge of automating its own research, how long until governments are forced to use AI to regulate AI? Human legislators writing bills that take 3 years to pass cannot govern a technology that evolves every 3 weeks. Are we building the tools to govern ourselves, or are we building the governor? And that's your daily dose of AI know-how from inuku.com, AI news you can use.